Yes, I was really happy to hear some of the talks of the electric universe because I've done a lot of research with plasma physics, vacuum arc discharge work, generating large amounts of X-rays, and so it's work that really coincides with what I have physically done in the laboratory, and I feel pretty good about what is being done in the field on the broader sense. Here I'm going to talk about something a little bit different, but it does fit in a little bit. It's my theory that I call the matter force. Basically, if we look at the four fundamental forces of the standard model, we see that mechanics is missing. And unfortunately, we can't figure out how all forces work until we have a better understanding of mechanics and how it fits into the force model. A force is a force, and mechanics has to be in there. One of the first places we can start to look at the importance of mechanics is understanding inertia. It's been mentioned previously by some of the other speakers that some people consider inertia to be an electrical type phenomenon, but that may not be so. One of the earlier people to make a prediction regarding inertia was Lord Kelvin. He came out with the gyroscope stat model, where he sees a rotation in the vacuum in response to the movement of matter. Now, this is very similar in concept to what Maxwell had in his magnetic vorticity theory in his 1860s presentations that became Maxwell's equations. And we can look at this in a more modern scope by looking at vacuum fluctuations. With magnetic inertia, we have basically self-induction, where you have a current running through a wire that creates a magnetic field. Now here I've taken the liberty of showing a magnetic field of rotating dipoles in space. And I do that intentionally because I have adopted a direct C type model for the vacuum. And part of the reason I do that is the Casimir force. Casimir, when he wrote his paper, the title is, includes the statement that it's a London van der Waals force. You cannot have a London van der Waals force unless you have dipoles. So in order for the Casimir solution to be correct, you have to have dipoles in space in the vacuum. And the only main model among popular physicists that meets that criteria is Dirac's model. Now, wouldn't it be nice if mechanical inertia was the same way? If we had a self-inductive phenomenon? If the motion of matter was integral with rotation of something in space, a matter-magnetic force, if you would. Now, one of the small-scale areas where we see this is tops and gyroscopes. If you can imagine, as a kid watching a gyroscope spinning and precessing about its axis, and not falling over, there's a force at work there, a force that's opposing gravity. Now, it's not opposing gravity in a straight up manner, it's a torque. It's being twisted, and the center of mass is still at the center of mass, but the center of gravity is at the base of the torque, or the base of the stand of the gyroscope. And if you put the center of the top on a balance, it will always weigh the same in the middle where it rests, even if the gyroscope is off to one side. And this cannot be explained by any of the four standard forces of the standard model. It's not electromagnetic, because we're talking about a neutral body, and it's not strong force or weak force, it's not gravitational. Now, one of the key things is, how does it do this? And also, what is it pushing against? If we put on our Faraday hat for a moment, we can say, well, there must be a field. That the gyroscope must produce a field that allows it to grab hold of the vacuum and allow it to hold itself up and keep from falling over directly the way it would if there weren't such a force. So we can alternatively to standard mechanics come up with a magnetic type solution. Now, I'm not the first to suggest this. Lathwaite would popularize some of those ideas, although he didn't go through the derivation very well. He also was criticized because he talked about flywheels causing lift and opposing gravity, but they're not really opposing gravity. You're changing the axis until the axis is vertical and then it stops. So it's not what he was claiming it was, but he was correct in saying that there's something interesting going on here that we need to get a better handle on. And it's something that's not discussed very broadly, even among groups of people such as ourselves. Now, to begin with, you can go ahead and make approximation, use a Biot-Savart law for point charges, similar to what you would do with point charges in electromagnetic sense, and produce a magnetic field that is based on some vacuum constant and then velocity vector r squared over your matter. And I'll just use the term matter. I'm going to avoid the term mass because as I'll talk about later, I consider that a separate issue. Now, as a way of an example, we can go ahead and compute the matter magnetic field of a rotating cylinder, thin cylinder, and we have, you can see the angular momentum, or you can have the angular inertia times the rotation frequency. And so you could simply come up with a parallel mathematical system that gives you the same answers that you get with the current Newtonian dynamic model, but you now can include a magnetic force, and a magnetic force that allows you to interact with the vacuum and have things move because of that interaction, not by magic. Now, one of the next steps we can look at in terms of misunderstood or not well understood mechanical forces are tidal forces and synchronous rotation. Now, it's true that when you have a body that's not completely spherically uniform with an even mass distribution, you do get a force that oscillates from back and forth depending on the area, but it's still a point-to-point linear force. And so the main effect of that is that you get a periodic displacement on the body being affected. And you get a very, very small rotational component to that. Now, the standard physics model says that that rotational component is significant enough to cause the tidal forces we see, but actually ask someone to write the paper or put the computation down, and they can't do it. What you see in a mechanical type, let me go back. What we see in a simple mechanical way is if you have a body moving with velocity v, it could be creating magnetic fields on either side of it. And then if you have a body rotating, it can create fields that oppose it. Conversely, if you have a field that's opposing rotation, it'll cause the rotation to slow. And what you see if you analyze bodies like in the solar system is that each of the body's rotation will eventually slow, and in the process that energy will be converted into having a higher orbit. And that can be explained very directly if you introduce a matter magnetic field similar to what we have with our gyroscopes and tops. Now, there's some discussion a little while ago about solar convection and also planetary convection. And maybe it may not be as necessary according to some as others, but it can be simply explained if you have a matter magnetic field. We know that differential rotation, which is the most popular explanation, isn't adequate. And some of the electromagnetic engine models don't seem to work quite well enough either. But if we take a line that is half the mass, it's at a radius of 0.79 r, and consider what its effect is going to be, the inner mass will create a counter-rotating field in the outer mass, and the outer mass will create a counter-rotating field in the inner mass. And in this way, the rotation of the overall body is converted into a convection current in essentially the mantle of the Earth, or the similar type of area in a star, which gives us an explanation for why we have molten mantle, and why when rotation stops, everything will solidify. Now, there's some good discussion on spiral galaxies just a little while ago. One of the key things I see in spiral galaxies is the outer stars appear to be held in more, and they also are rotating much faster. To me, that points to a Lorentz force, but it's mass times velocity times the magnetic matter field. And so that these outermost stars are being pulled in because of their rotational velocity is very high. And also the field is very high because the stars that are nearby are producing a large matter magnetic field. You also have another thing that's related to the parallel conductor effect. Parallel conductors are drawn to each other when they have the current going in the same direction. If you would have two stars that are each creating matter magnetic fields that are headed in the same direction, those stars will be drawn toward each other and effectively will be drawn into bands. Now, Don Scott kind of beat me to the punch with this one. Pratt made some very important models of galaxies using strictly an electrodynamic method, using Maxwell's equations. And in my mind, he essentially proved that the structure of galaxies is not related to gravity at all, but it's related to Maxwell's equations. But the important thing is, to my thought and to this paper, is his models normally criticized because people will say, well, most of the matter is electrically neutral because you have positive and negative charges in close proximity, so from any distance it's going to be neutral. Yes, you do have filamentary structures in that as a component, but in order to get in the broad scheme of things, you have to have the electrically neutral matter also participating in these Maxwell equation-based interactions. And so, in my opinion, it takes both. It takes both the electromagnetic effect due to the electrical universe type theories, as well as a matter magnetic effect as described here. Now, going on to some general relativistic effect. The de Sitter effect is based on a general relativity theory, but it can be described as a matter magnetic field alternatively, where two bodies that are moving relative to each other will generate a magnetic field between them. And you can use that magnetic field to generate the de Sitter effect without having to go through a general relativistic explanation. Similar thing with the Lenz-Therian effect. With Lenz-Therian precession is rotationally based. And if you have a matter magnetic field, the rotation creates this magnetic field, and then you have interactions based on that field. And it doesn't require general relativity. Next, you move to the precession of the perihelion of Mercury. With that, we have a case where essentially the de Sitter effect, as it's called in general relativity, you have a matter magnetic field developed by The movement of the body develops a field propagating from the sun outward, and that field creates a force that is everywhere tangential to the velocity vector of the orbiting body, in this case Mercury. Because the velocity vector is not pointed directly toward the sun, it creates motion. Danby, in the second article, in the second version of celestial mechanics, goes into this, and you can show that it creates a periodic motion that oscillates back and forth, but there's also a secular motion that allows it to precess. This is also, Tom Van Flander did a good article where he, instead of having a matter magnetic field, he came up with a theory of ballistic slowing, relativistic slowing, that introduced a pseudo force that was tangential in this way, and comes up with the same answer. And I've heard a couple people in the audience that have mentioned that they've done similar things in their theory. But you can get at it more directly if you institute a matter magnetic force and have this oscillate, these forces occurring, which leads to the precession that we see, without having to have any general relativistic effect. And more broadly, if we look at light as a standard with Feynman diagrams, that over every half wavelength it's equivalent to a virtual particle pair that's rotating 180 degrees. And that's a way that you can see that it develops both the electric and magnetic field. Because of that, you have a particle pair being rotated, and that pair will have matter, and it will be affected by gravitational mass if there's a matter-magnetic field. The effect of the mass causes the slowing of the rotation, or shortening of the rotation, to be more specific. The actual distance is lowered while the frequency stays the same, and that gives you slowing such as what we see with the Shapiro delay. You also get bending, redshifting, and clock slowing for exactly the same reasons. And none of this, if you have a matter-induced magnetic force, then none of these so-called proofs of general relativity are necessary to, you don't have to invoke general relativity to get any of them. You can do it strictly with a magnetic force. Now, historically, some people have tried to play with theories of this nature where you have a magnetic field. The first to do a mathematical solution was Heaviside in the early 1890s, and he did it not long after he was working with coming up with the vector equations for his variation of Maxwell's equations. And then R.L. Forward in the 1960s came up with the relativistic effect, coming up with that. And then more recently, Tamar's been an advocate, and he has done experiments with flywheels, and he's actually measured, and it's about 8 orders of magnitude lower than the electrical effect, but he's measured a net positive effect that is anomalous, that he thinks is due to the motion of the mass of the flywheel. The problem with gravitomagnetic type theories is mass can't be the charge. There is no negative mass. And then mass is not an intrinsic property of the particles to begin with. It's a property of energy. And on that note, I'll go ahead and pitch another paper I did. If you take Maloney's, this is a general equation for the energy density in a vacuum. I took it from Maloney's Quantum Vacuum, which is an excellent book if you want to get into quantum vacuum theory. And if you assume that a proton or electron is the size of its charge radius, and you treat this as a Casimir cavity such that wavelengths that are the length of diameter, the inner or outer diameter, and everything in between are excluded, you find out that the energy density excluded is equal to the mass for the proton based on its charge radius, and also for the mass of the electron based on its charge radius, which I take to be the Compton radius. And so one can get a simple explanation of the mass using this well-known computation, and also the 1836.16 just falls out. Now, another problem is gravity is not the matter force. Gravity only works in one direction, and it's the wrong direction. So what is gravity? Well, I think it's dark energy. One of the main problems I have with physicists who talk about dark energy and the expansion of the universe is that if you have an acceleration, you have a force, F equals ma. And that acceleration means that there's an unidentified force. And physicists are failing us by not treating it as an unidentified force. They're trying to sneak it in the back door or treat it as something else. If you treat it directly, now you have a force that causes matter to move away from matter. And not only would it be responsible for the accelerated expansion, it would be responsible for the expansion period. And on the opposite end of this, if you have that as an expansion, you would need to have an attraction to go with it. It turns out, and I didn't put it in the paper, but I had a discussion with a researcher at the University of Texas recently who's looking at positron emission topography for scanning for health reasons, and they have a puzzle. Their puzzle is that the positrons are absorbed far too readily. Then they're absorbed more readily, a higher absorption coefficient than electrons, even if you take into account the difference between the absorbing electrons being in the shell and a nuclei. Even if you make corrections for that, it still doesn't fit. They don't have a physical model that explains why positrons are absorbed more readily. So if you're thinking, well, there isn't any evidence for it, well, there is. There is evidence. And it's something that physicists are talking about behind closed doors, but they're not publishing because no one has a good answer yet, or even a good theory to talk about it. So what is a charged dipole? I just threw up the basic physical, most physical constraints. And you have, of the most basic dipoles, the electron and positron. And you can see they have opposite charge, which we already accept as charge, and we have a magnetic moment to go with that. Spin is in the charge, mass is in the charge, lepton is definitely not a charge. That only leaves one thing: matter and antimatter. And while I was stunned when I first came to me that was really the only answer, and it took me weeks to get past it and actually start to work with it. But if you think about it, it's a form of energy, and just like you can think of electric charge being a form of energy, and you can think of them operating in exactly the same manner. And what you can get from that is that, going back to my vacuum fluctuation Dirac C model, is that when you have a body of matter in space, you can get orientation, and then you can also get repulsion, and you can get a magnetic field. And because you have two fundamental types of charge orientations, electron-like and proton-like, where you could have, in the case of protons, you have positive matter with positive electric charge and antimatter with negative charge, and the opposite polarity with electrons. You can have one of the charges canceled while the other one's being active. And that allows us to have one field without the other. And we can also arrange this, and I just use simple integral form because I like the way they look better than the vector form, into the standard laws that we see, Gauss's law of magnetism, and I just use subscripts there. These coefficients need to be worked out depending on what units you decide you want to use. I think it's better to use units that you would use for electric charge as well, because it makes it easier to combine the two. And that's the next slide, is that because you have charge-carrying particles that have both types of charge, and both sets of charge follows the same sets of laws, then you have to combine the two into a single electro-matter force. And since they're just two embodiments of the same force. And if you do that, then you really do have an electric universe with everything being described by this one force. And then I'll end with a shameless plug for my recently published book. It's available on Amazon for a Kindle reader.